All right, so as I promised you yesterday, that we need to work on doing the row operations, right, to change those matrices into either row echelon form, right, or hopefully ultimately we can do the reduced row echelon form. But before we dive into this kind of a lengthy, complicated, not complex, just complicated, algebra, we need to understand why we have to change them into those two special forms. So the method of solving linear equations with matrices is called the Gaussian elimination. Do you guys recall the name? It's the same guy. The same guy came up with that fancy way to add up the arithmetic sequence, right? So elimination, as you can probably tell, that's a classic method of solving equations. But this guy, I can't believe that it's back in the 18th century. So people has figured out how to deal with a whole bunch of numbers at the same time and do some kind of a interesting, mysterious operations just to the rows, and you were able to solve the equations using matrices. Okay. But you need to understand at this point that the matrix method is not designed for us. It's designed for machines. Okay. Wait, does that surprise you guys? But okay, why not? Oh, well, that's a good point. It's either that is, it's just not user friendly, right? But of course, I want you to understand, even if this method is not designed for a human, but then why do I have to learn it? Why do I have to learn how the machine likes and how the machines are thinking? That might not be a math question. Sure, why would I pay you $1 million a year? Then you don't understand the algorithm behind those programs, right? Or, I mean, it just so happened that we're learning matrices, right? Or we're learning a matrix. And you guys told me about that movie, right? Matrix. So you see what happens if you don't understand what's going on with those machines. What if they do take over? So I don't think it's going to happen anytime soon, right? But I'm saying that this is why, if the machine can do it, you should be able to do it, right? And because you will be the one to control and design the machines and know what's going to happen if you don't do it right. So again, you understand that even though this is not designed for our brains, but we should be able to process and understand what's going on, or at least that do it once, right, to see what happens. All right. Now, what is Gaussian elimination? You start with a system, right? However many variables, however many equations. And that's how powerful that method is. You extract those numbers, right? As soon as you line up the x, y, z, right, and also the constant on the right-hand side, and put them in a matrix form. So this augmented matrix. So you're gonna try to do whatever it takes to change that matrix into a row echelon form. Okay. So now feel free to read through, right, those steps. I just have to warn you. So things might be a little bit different, right, than the question bank, again, because it's not the same person who wrote this question for the question bank, even from the same question, publisher in the same book, right? So whoever wrote the book, and they hire someone else to do the questions. Okay. Now let's make sure that you guys are okay with, at least in the notes. Take a look at that, the row operation right there. Oh, shoot. All right, so what does this tell you? We are changing row 1 or row 2? Row 2, right? But somehow didn't say take the -3 times the row 1 and put it right in front, right? It's a subtracting 3 times the row 1 from row 2, but you are going back to row 2 to change it. So row 1 stayed the same, but row 2 is going to be the one that's updated, right? Not that big of a deal, you know, but as you read, you understand what those notes are telling you. And also in the test, please make sure that you, as long as you have time, right, put down those comments, because that will help me to find out what steps that you do right, at least conceptually, so I can feel like, you know, giving you some points for. Does it make sense? Because it's FR2, right? If you don't do anything, how am I supposed to find out as you're going from those numbers to some other numbers? You know, I can somehow magically tell that what you did, right? But if I see that, oh, you're doing the right thing, you know, because you're trying to get the 1 by doing this, somehow you didn't get it for some reason because it was a math error, right? So I mean, at least that you're on the right track to getting the, you know, getting things done, right? Now let's take a look at the beauty of this row echelon form. We'll figure it out by hand, you know, how we get to, you know, a form like that in a minute. But let's appreciate this form when it comes to solving the original system. So now we need to go back to the system. So by interpreting those rows, right, as the coefficients and constants for the equation. See the first row, that 1 is the coefficient of x, right? That 2 is the coefficient of a y. -1 is the coefficient of a z, right? So you basically get the left-hand side of the equation, and the right-hand side will work out as a 1, right? So that's basically translating the first row into an equation. And you do the same thing for the second, the third row. Now the good news about the second, third row is that you're getting more zeros, right? You're getting less and less variables, right? So the second row has no place for x anymore since it has a 0 coefficient. Not to mention the last row, it's just z by itself, right? And you see right off the bat that even though that we don't have the solution right away, but at least that we figured out what the z is, right? That's our goal, right? We want to solve for x, y, z. As you can see that they will use something called the back substitution, right? So what it means is you now need to go from the very bottom and substitute the z back to the previous step to find out what the y is. Okay, and now y works out as 1, right? So now once we have the z and a y, put them back into the first equation to get what x is. And this process is called the back substitution. Yes, Lucia. So that's what I'm going to show you in a second in reality. So then I'll let you know what I think. Then later on, of course, you don't have to think the same way when it comes to, oh, do I have to take a half? Do I add a certain multiple to another row? But you want to understand the strategy behind it, right? And then once you get it, then of course, you know, I encourage you to go back, you know, look at those examples that I typed up for you to understand why they choose to do a certain row operation, okay? So, well, usually it goes either from whatever they told us to do, right? You understand it, then go try, you know, on your own, right? That's usually, you know, what we like to do. But right now, let's be practical. I want to see just by diving into those row operations. But I'll go let you know, I'm telling you, if I were the student, what do I do, right? What's going to bother me, right? What are the common mistakes? Once you figure it out by following my work, and go back and see, oh, that's why they're trying to do -5 times the second row added to the third row to do something about it. Okay, so either way, okay. So read the examples I typed up, but I'll you know, I will prefer that you you know, work out something, you know, together with me in a second. Okay. But the point is, do you see that once you get the row echelon form, it doesn't take a lot of effort or almost no effort to find out what those solutions are, right? And the method is called back substitution. And this whole process, starting from the augmented matrix doing a row operation to get the row echelon form, right? Recover the equations, then do the back substitution to get all the XYZs. That's called Gaussian elimination. And the question is going to say, use Gaussian elimination to solve that system. And that's what you have to show me if it's FRQ. If it's not FRQ, then you figure out however you can with the calculator. Okay. Now, I wish everyone, is gonna, work out letter B together with me, and all you have to do is just follow along. And the reason why I want you to seriously follow along my work is not just by completing the work so that you can refer to it. You need to check my math because even though those simple numbers, I might say something wrong, or while I was talking, I might do some mental math wrong. Right, so we have a system with 3 equations with 3 variables, right? I'm going to need a augmented matrix with 3 rows, right? Each row stands for an equation and 4 columns. So the first column, 3, 1, 1, right? The coefficient for x. Second column, 1, 1, 3. Third column, 2, 2, 2, right? The fourth column, 31, 19, 25. Okay. Now, if you decide to put a divider so that people know that the last column is for the constants, you could. So I don't feel like you have to do it, or at least that I'm kind of lazy. I don't want to keep drawing the lines, right? So you know that the last column is not for those coefficients. So now, you guys go ahead and picture the row echelon form in your head, just for a couple seconds. And then look at this matrix. And think about what should you do to get started. What does the row echelon form look like, right? What are the most important things you're trying to get, right? So now what happened here? Does it look the way you want? No, right? What's wrong with it? It's not 1, right? Which element is not 1? 3, right? Good. So now you see that every time, of course, there's no reason why, but we're expecting the first row, first column, that top left corner, that number better be a 1. But it's not 1. So now you think, what options do I have? I can interchange rows. I can multiply a row with a number, or I can add a multiple row to another one to update the row, right? So there are 3 options. Whichever order, whichever combination, whichever kind of operation you can do, right? It's fine. It's up to you. But based on this matrix, which kind of operation? Interchanging rows, right? You see that this is probably the best option. But you know what? The computer doesn't know that's the best option, right? And also, I have a student in the morning class. He likes to deal with things in a more routine way. He said that, why don't you divide out the 3 in the first row, or take a third of the first row? Is that allowed? Yes, right? Is that good or bad? I mean, it depends, right? So I'll say that for me, I don't like to deal with fractions because I'm worried about getting it wrong, right? So I mean, it's okay if you always type things up in the calculator, right? Then I'll say that, yeah, whatever element you start with, if it's not 1, divide it out. But in this case, you might get a lot of fractions, right? So in this case, let's swap rows. And the notation for the comment is just like you guys are a programmer right now, right? So when you code, better put the comment so that people can read your codes. So I'm going to go with R sub 1 and a 2-way arrow, R sub 2, so then people know that, oh, I'm switching the 2 rows. So I'll put 1, 1, 2, 19 as the first row, 3, 1, 2, 31, 1, 3, 2, 25. Okay, and I'm going to box the first one, and it's the leading one, right? And the reason why I box it is to make sure that we've got it, right? Better not to change it, And also keep using that 1 until you're done with the first row. Okay. So now you guys remember that to be a row echelon form, all the numbers right underneath that 1 in that column must be 0. Right? That means I need to have a 0 here and a 0 there, right? Not 3 and a 1. So now you think about what you can do with the row operations to kill that 3, make a 0. And I said that please use the first row, especially that 1 we just got. Your options are interchanging rows, taking a multiple of a row, or taking a multiple of a row but add it to another row. All right, now, go ahead. Anyone have yeah, go ahead. What did you say? Good. So, and Emmanuel said, why don't you take -3 times the first row? And I'll write it down what it looks like once you take it -3 times. So 1 times -3, -3, right? Here, -3, here, -6, right? This is -57, right? Am I right? So now, even though I wrote -3 times the R1, I'm not going to change the first row, but I'll take -3 times the first row, but add it to the second row, right? So let me put down a comment here. So we'll do -3 times R1 added to the R2. And as you know that, this means that you're going to change R2, right? So let's do that, element by element, number by number. -3 added to the 3, 0, right? -3 added to the 1, -2. -6 plus 2, -4. -57 plus 31, 26 negative, right? Now, row 1 stays as is. Row 3, I didn't get to that. You guys with me? Okay. But do you realize that we could have done the same thing to the third row, right? Not exactly the same thing, similar, right? How would I kill that 1? Subtracting the third row from the first row, or subtracting the first row from the third row, or let's say the more conventional way to say it is to take -1 times the first row and add it to the third row. It looks funny, but people like to see those kind of patterns, right? Now, you don't have to put down those things like I wrote in a different color. I do that so that you guys know exactly what I did. All right, so now, do you see that I tried to put something right underneath, right above something so I can see closely? Because again, I get paranoid. Sometimes I'm not looking at the same number, right? I want the numbers to be close enough so I can see later on I'm going to add up the numbers. So take the first row, but flip the sign, right? -1, -1, -2, -19. So then you're going to add, right? -1 of the first row to the last row. So now, if you don't mind, so you know what? Let me not make the notes so messy. All right, so I'm going to write a new matrix. All right, so if I do, oops. -1 times the first row, right, added to the third row, right? So it's going to look like 1, 1, 2, 19, 0, -2, -4, -26, right? And the last one, it's -1 plus 1, 0, -1 plus 3, 2, -2 plus 2, 0, -19 plus 25, 6, right? right? So again, we'll make sure that we keep track of the leading ones. So now would you say that we have cleared up the first row, right? By having the leading one, we have cleared up the first column since none of these things are, things other than zeros, right? So I guess we should, move on to the second row, right? Again, remember that the row echelon form says you need to have a leading one strictly to the right of the one right above it. So I better get a 1 here, right? Or here, but anyway, why not? Start from here. How do I get? Oh, no one see that? I put a typo there. See that? Well, thanks to technology, right? So now, most likely, you guys don't do it by hand anymore. Oops, what the? Anyway, what do I do next? If I want a 1 here, your options are still interchanging rows, take a multiple row, or take a multiple row, add it to another row. Interchange with all right. You guys are correct. You guys are correct. So as long as you are getting a leading one here without changing the first row. So people like maybe the third row, since you have zeros, right? Swap and divide out the 2, right? You could do that, or take a half, right? Or people say, well, why don't you just divide out -2 right out the bat, right? Why not, right? Well, with BLAST that these numbers are nice, right? In general, you probably don't get to find any common factors. So let's do -2, -1/2 times the second row. So that'll take, now the 0 is still 0, right? -2, take a -1/2, right? Or divide out a -2, that's 1. -4 divided by -2, it will be 2. -26 divided by -2 will be +13, right? The first row stays the same. Oops. The third row, and again, we didn't do anything about that. Now in this case, I choose not to swap rows and just divide out the numbers right off the back, is because if I do a swap, then I divide out, that's like 2 steps, right? Because the more steps you do, that more likely that you might end up making some mistakes. Anyway, so now you tell me, what do I do next? Are we done with the second row? What about the second column? We haven't cleared up that too, right? So all the numbers underneath the ones in the same column must be 0. So I need to get rid of that too, right? Now, how do I do that? Right? I need a 0, right? So the way to kill that 2 and then make it 0 is you add -2, or you subtract the 2, right? But you're going to use that 1 to get yourself a -2, add it to it. Or basically multiply the second row by 2, subtract that off around the third row, right? Because you want a 0, not a 1, okay? So let's take -2 times the second row added to the third row. All right, so now if you want, you can put -2 times the second row to make sure that you definitely get what it is. So it'll be -2, -4, -26, right? Now, do you see that I didn't even bother to put down anything for the first element of the second row? Because whatever that is, it's going to be a 0 anyway. You see that? You guys see what I did? Okay. And that's why, you need to clear out that column using that 1 before we move on to the next row. Get those zeros ahead of time, okay? So now you're going to add those numbers, right? So -2 added to the 2. Oops. All right, so -2 plus 2, 0. -4 plus 0, -4, right? -2, 26 plus 6, -20, right? Second row still the same as before. The first row, again, it never changed. Now, do you see that? We've got the first 2 rows, right, with the leading 1. We cleared up the elements right beneath those leading ones. So now we're ready to move on to the third row, right? And then work on this one. Yeah, Lucia? Say it again? Right, so 3 1s. Oh, thank you. What am I? Yes. Another 2 mistakes. Oh. Thank you. All right. You know what was back is, you know, back in my high school, students not going to say a thing. They probably didn't see it, or they weren't even pay attention to. And what happens is, after 20 minutes, I thought I did a perfect job, right? Let's see if it matches. No. And I go back, spending another 20 minutes to fix the error, and nobody's going to say a thing. All right. I guess that they're just nice to me, right? They don't want to point out the errors. Now, guys, what do I do next to get the third row ready? There you go. Divide out the -4, right? Okay. All right, so it'll be 0, 0, right? -4 over -4, it will be 1. -20 over -4, it will be 5. All right, so 1, 1, 2, 19, 0, 1, 2, 13. Oh, shoot. 13, right? Let's block those ones and do a quick check to see if that's indeed the row echelon form. Right? Sorry about things not line up perfectly, but you get the idea, right? So 3 by 4 matrix. All right, any questions so far? Go ahead. It depends on whether it's an FRQ or multiple choice. If it's a multiple choice, you do whatever that you can, you know, do in a test, right, to get it right. If it's FRQ, then you do have to show me those work. Yes. Wait, because they're laughing, I wasn't able to hear the last part. It depends on how off it is. All right. Now, well, let's put it this way. Since you see how long it took me, right, and I might end up making the errors if you guys didn't, you know, point it out, right? That means what I'm checking, at least that's what I can only speak for myself. What I'm checking is if you understand the method, if you know what to do, and the best way to see if you know what to do and to convince me that you know it in a test is to show me those comments. And also, if people are having the row echelon form scramble in a way that the 1 is not strict to the right, oh, that's wrong. If you're off, that's not a 1, that's a 2, that's a 18 for some reason. I mean, there's no way I can go back in and spend minutes to check your work to understand why you make that mistake and find a way to get you the points. So all I can justify is student gets most of the part, you get most of the points, right? But here's the thing, even as FRQ, do you know how to get the answer correctly first? Yes. So why would you show me a wrong answer at the end if I don't have the time to check everything? I hope you understand what I'm saying. Good. So now, before you guys take the break, I want you to translate that row echelon form of this augmented matrix into that three equation for three variables about x, y, z. Solve them using the back substitution. Right? Once you're done, you go take a break. Right? Again, just like we did, right? Write down the equation of x, y, z's, interpreting those columns as coefficients and constants. Solve for the x, y, z. Go ahead. All right, so if you're done, go ahead and take a break. Then if you haven't, just quickly get it done. Then go take a break of 10 minutes. All right. 10 minutes, calm down.
10 minutes starting now.
Later on, so this is my pre-apology.
Wow, you're bribing me.
I'm just saying I'm sorry for the anger I have towards you right now. The anger I have
Wait,
towards
you have
this.
anger towards me? Why?
What the hell is How do they all understand? Oh yeah, we should do the negative two. No.
Well, my last name is Wang, not Gauss. So, all right. So I don't take the blame from this guy, right? But I'll appreciate the. Uh, okay. I guess that I didn't teach it well enough to deserve an apple. Thank you. That was me right now. All right, since you guys are back, so take a look at the answers. But of course, I don't think that will be causing any issues, right, when solving for the XYZs. Now, in a book, they do want our students to write the solution in a way, or at least that you need to be able to understand when the questions, like multiple choices, might list the solutions to those linear systems in a way that's not very intuitive. Okay. Right. So it turns out that so now we are actually working on not just math anymore. We need to make sure that you guys are able to actually communicate with people in the field, right? So as if that you are a math professional, then you need to understand that people don't simply say, oh, XYZs are whatever, right? They'll say you will have a solution set. That means you might not always get, one solution. Not to mention in this case, when I say one solution, it doesn't mean one number, right? It means a ordered triple. When I say ordered triple, it's a three-dimensional point with x, y, z, right, which are the rectangular coordinates, right, at 6, 3, and 5. Okay. But you'll see in the future that you might have infinite many solutions or non-solution at all. Okay, so therefore they want to make sure that we are acknowledging that systems might have more than one solution, so we call it a solution set. Right? And the way to build a set is to enclose your solutions with a pair of curly brackets. Okay. But you need to tell people that the set is about a whole bunch of ordered triples, right? So it's in a form of open parentheses x comma y comma z close parentheses. And again, it's like a three-dimensional point such that the vertical divider is basically letting people know in general the solution is going to look like that, right? But in this particular case, we only have one possibility for those XYZ. So it'll be 6, 3, 5. Okay. I know that looks unnecessarily complicated, right? Or probably you don't see any point of doing that. It's just that it's probably fine right now if you choose not to write your solution like that in a test, but you need to understand when people write things like that. That's all. Okay. Know that it's nothing but specifying the solution of that system, and there's only one, quote unquote, one solution, but that solution contains 3 numbers. It's a ordered triple. Okay. Now, like I said, realistically, if it's FRQ, then you need to figure out everything up, from the original matrix with the row operation, get to the row echelon form, back substitution, get the right answer, right, with reasonable amount of time. Therefore, if there will be a question, or hopefully one question like that, so you know that you're gonna have to save enough time for that, right? But of course, you want to also think about that if it's worth to spend a lot of time on a question like that, right? Because it's gonna work. Let's say if there are 5 FRQs, one of the FRQs like this, which can easily take you up to 20 minutes if you seriously want that 5 points. But I mean, you could have got the 5 points somewhere else, right? Or if you have time, come back and show me the things that you know what I'm expecting to see to get 2 out of 5, 3 out of 5. Because if you're losing 2 points out of 5 for a question like that, I don't think that's really as bad as you thought. But if you have time, figure it out, right? But like I said, there shouldn't be an issue for getting the right answer, right? Not to mention, there's no way that you'll be able to get anything wrong with the row echelon form because you have a calculator. It's just that you might not be able to get the work done perfectly somewhere along the way, right? So let me show you in a calculator. And we don't have the time for you to play with it, but you do that when you get home. Remember that, try the first 12 questions, right? Or as many of them with the calculator as you can. So let me show you what's going on with the TI-84. So I typed up, I hope that I don't have to show you all the detail, right? So go to second matrix, right? So I typed up a few matrices, for our future use. So letter B, for the B matrix, that's for the example letter B on the packet. So make sure what it looks like. All right, so that should be exactly the one, right? We worked out. So now we need to have the row echelon form, right? So all I have to do is, again, go to second matrix, right? Go to math, scroll down, find REF. Hit enter, right? So you're going to feed it with the matrix B. So again, second matrix B, right? Just type in the 2, right? Now, just to make your typing a little bit elegant, so close the parentheses. Hit enter. There you have it. Okay. Now, of course, it doesn't look like the one I got, right? I'll explain in a second. But the first thing you need to resolve is how often do you see answer choices on our test that has a lot of decimals in it? Not very often. So most likely those numbers, if they are not integers, they could be just fractions, right? So you need to know that this calculator, that's why I'm asking everyone, at least for our summer course, to get a TI-84, from the library, because the fancy model, right? So you can go to math, take the first option. It's going to turn whatever answer you worked out, right, if it's a matrix, and turn it into a fraction. Well, turn it into the fractions. And there you go. And now you should be looking for those options that has to correct the fractions, right? But still, how come that it doesn't look like the one I worked out? I mean, it is row echelon, right? The last one matches, right? The last row. But what happened to those guys? Or would you be able to guess what the calculator did and end up getting those fractions? They divided the first row by 3. You see that as human, we don't like to do that since, it gets, the ugly numbers, right? But calculator doesn't care, right? They have pretty much infinite computing power, right? They'll just do the most brutal way to get what they want, or to get what you want, right? But nothing bad at all, right? But if you're confused that you thought that we did something wrong, that's not the case. This matrix and the one we got, right? They're both row echelon. They don't have to be the same because you know what? They are only off by a few more rounds of row operations. And I don't even care to get those row operations because either way, if you translate that matrix into the XYZ equations and figure out what the XYZs, they're going to be the same. So now think about if you had to do it by hand, why would you get fractions? But in our test, anything wrong with you put down that fraction? Well, the matrix with those fractions? No, absolutely not. But you have to somehow figure out a way to convince me that you were able to get that, right? Because if you only show me the row echelon form with nothing, like any relevant work, then I'm assuming that you just, don't care about those 2 or 3 points, right, for the steps, okay? Now, let's take a look at the reduced row echelon form, because that's what we're going to get into in a second. So we're going to take the reduced row echelon form of the same matrix. All right, I'll feed it with matrix B. Okay. All right, take a look at that. Do you see how nice it is? What about those numbers? 6, 3, 5. They are exactly the solution you're supposed to get. And they're ready to go. You see that? You don't need any back substitution, right? You just need to reduce the row echelon form, and the answer is right there. Right? But you thought the machine knows that you want the answer just because you want the reduced row echelon form? It doesn't. It just do whatever you asked it to do, right? Someone has programmed the calculator and do the row echelon, the row operations, right? So you were the one to get rid of those XYZs and just type in the numbers, right? And the calculator do the algorithm to spit out the numbers, but you interpret the numbers as the solutions. Machines doesn't know anything going on, okay? That means that row echelon form you saw on my work looks different from the row echelon form the calculator got me, right? If we were to put both our row echelon form into the calculator and get the reduced row echelon form, they guaranteed to be the same. And therefore, row echelon forms might be different, right? They might be off by certain row operations, but most likely for reduced row echelon form, it will be the same because it guarantees that you get the right answer, okay? And therefore, we need to look into the reduced row echelon form. So now the question is, how would you get that by hand? Now I'm going to skip letter C because that's trivial, right? So you just, type it in the calculator. I'm not going to do that. If you feel like doing it on your own, do it after class. So what's interesting that there's another mathematician figured out, you know what? I'll just do a few more steps. Once I get the row echelon form, to get to reduce the form, and the new method is named after both. Well, Gauss, of course, the first guy, right, came up with the Gaussian elimination, and the mathematician, named Jordan, right, he figured that let's do a few more steps. So when they say Gauss-Jordan elimination, it means that you're going to start with a system and its augmented matrix, right? Do whatever it takes to get to the row echelon form. Okay, see that? You have all the ones, right? All the zeros, right? Right beneath the one, all the zeros to the left of the ones, right? So that's the row echelon form. But now you need to get to the reduced row echelon form. So now what you have to do is those 3 numbers need to be 0. Right? You guys remember? The reduced form require that not only the numbers right beneath the leading ones, also numbers above the leading ones are supposed to be 0. So we just have to do pretty much like 3 rounds of row operation. Right? So another question is, say, how would you get rid of that 2? How would you change that 2 into a 0? First off, which row would you use? Second, why not this guy? Right. Either 1 is not in the correct place to kill that 2, or you have a 0 there, right? So therefore, you're going to use the row that has the leading 1 in the right place to get rid of certain numbers, right? So I guess they can see take -2 times the second row, right? Add it to the first row to get rid of the 2. Same thing for the -1, right? So you're gonna add the third row to the first row, or to kill that 4, you're gonna take -4 times the third row, add it to the second row, right? So now the order shouldn't really matter, whichever number you want to get rid of first. But there is a order that you will be better off to do, so that you don't end up going back and forth. Yeah, Zach? Exactly. So I'm glad you noticed that. It's basically by blending the back substitution into the row operations. So I'm glad you raised that question. So now, does it mean that I was teaching you something that's completely different from the traditional method of solving system equations? No, we are still doing the addition method, the substitution method, right? But we make it in a way that the matrix, right, will be able to deal with all that many equations, all those numbers, all at once, right? And that's what you should be doing as a scientist or engineer, right? Once you came up with a design, then you need to make sure that it will be a massive production. You need to improve the efficiency, right? And to get the profit, right? So if you have unlimited resource, you can build whatever you want, right? But the question is, we don't have unlimited resource. And matrix is, again, to making the process that we're used to, but a lot more efficient. Anyway, now back to what I was saying. So there is a preferred order that you should be killing these numbers. So I suggest that work your way back. As you get into the row echelon form, right, you're going to finish with the last row, right? I want you to use the last row to kill the numbers right above the third leading one. Then once you get rid of these 2 zeros, get to that 2. You'll see why if you try it, because if you don't do that, you end up changing those numbers back and forth. Later on, you're going to kill them to be, make them 0 anyway, right? Why don't you get them zeros first? Then you don't have to worry about them anymore. Just get rid of that 2, right? But I mean, most likely, people are not going to do the reduced row echelon form. The reason might be kind of simple because, you had enough of those row operations, right? Once you see how it works out, there's no point of actually doing it anymore. Not to mention, just like Zach said, isn't just back substitution, right? But was hiding behind the scene. Yes, it is. Okay. So now, a very realistic question. The FRQ in a test asks you to use Gauss-Jordan elimination to solve that system, and you have to show me all the work. All right. So what you should do is start from the matrix, do what you have to do to show me the correct row echelon form. You know that this can be cross-checked with the calculator, right? Make sure that the answer is right and the work is relevant. So now you could, if you want, do a few more steps to get the reduced row echelon form. But if I were you, I'll use the calculator to get the reduced row echelon form, if that's what I demand. Right? Does it make sense? Because if I said that, all I want to see is you guys know how to do the row operation. I've seen already from the work up to the row echelon form. I don't need to see any more work. You get it, you get it. Okay? But you need to get the answer correctly. Not to mention, this is the way to go. Right? If you want to solve for equations, don't you think that you don't see the solutions right away? And if you're not the one to do the reduced row echelon form, let the calculator take care of it, and you can just read off the answers. And that's what you should do in the multiple choices. Does it make sense? The multiple choices, for example, like one of the questions, look, number 6. They say use Gaussian elimination, back substitution, right, to find out what the answer is. I mean, who knows you didn't use the back substitution, right? Use the, the RREF, get the reduced row echelon form, read out the solutions, and that's how quick it's supposed to be. Okay, and that's exactly what you need to practice tonight to make sure that you get it done within a minute or 2. Okay? Seriously, type it up. How long do you think it's going to take you, right, in a calculator? And also, you don't have the time, to go back and fix all the things, right, in a calculator. You go back because you know what? the quiz might have matrices, you know, with a little bit bigger size, right? 4 by 5, right? 5 by 6. 5 by 6, there are 30 numbers, right? If you keep messing things up, you know, or getting those negative signs and stuff, you know, and going back and forth, and not to mention that the worst case is, you know, the time is ticking, right? So you get, you know, stressed out, and, you know, you probably, you know, not getting what you're supposed to get. Anyway, right, so I guess that we're good on the Gauss-Jordan elimination, right? It's just getting the reduced row echelon form. So I'm gonna skip letter E because that's exactly what the problem that we worked out with Gaussian elimination, right? See, that's the same system. Basically, just do it one more, well, a couple more rounds, right, by hand if you want, but I don't think you really have to. All right, now, there's something interesting I would like to show you. You know, once you get to the row echelon form, to think like a mathematician, instead of solving things, they're able to tell what's going to happen, right? And that's really what make them, you know, different from, you know, our students, even instructors. And that's why, you know, it's the thinking that I hope that you're getting around those classes instead of just those problems. They say that look at those 3 row echelon form. They claim that the first, you know, matrix corresponding to a system that has no solution because something wrong with the last row. Now, why is that? Say it again. All right, so what's wrong? Exactly what's wrong with the last row? What does it mean? 0 equal to 1. That means 0x plus 0y plus 0z is equal to 1, right? That's not going to happen. So hopefully you will see that if you have one of those rows that looks like that with a whole bunch of zeros and one number at the end which is not 0, that's a contradiction. And you should stop, right? If it's FRQ, you said no solution, period. Okay. Now, what about this one? You have those ones. Right, they're called leading ones. So now here's some fancy concepts. You know that the first column represents the coefficient of the first variable, right? Let's say x. That's y, that's z. Whichever column has a leading one, the corresponding variable is called a leading variable. That means here the x is the leading variable, y is leading, also z is leading. And you do realize that there's only 3 variables, right? If all the variables in the system are leading variables, that system has and only has one solution. Again, when I say one solution, in this case, it's one order triple with x, y, z given certain numbers. Okay. That means the third matrix, as you can see that since there are 3 rows and 4 columns, oops, there's still 3 variables, x, y, z. But z is not leading, right? Why is that? Because that third column was supposed to be about the z has no ones, right? There's not a leading one there. X, y are leading, right? But z is not. So now you have infinite many solutions. But here's the thing, infinite many solution doesn't mean that all numbers you can come up with are solutions, right? Therefore, we're going to look into a system like that, which is called dependent system. I guess you've heard of it, right? The system like that, you know, has no solution is called inconsistent. But the one here is called consistent because it has solution, but independent. Okay, so let's see what's going on with the dependent system. So here's the system, right? So now I'm assuming that there's no issues for you to, you know, get the row echelon form, right, or even reduce row echelon form, right? And I hope that you see right off the back that system has no solution. You see that? The last row, right, is a whole bunch of zeros and non-zero number at the end, right? Now, that system, and again, if you type it up, right, and get the reduced row echelon form, so now you're looking at only two leading variables, which are x and y, right? And the z is not leading. So now what they have to do is they will again rewrite that system in terms of those coefficients in the reduced row echelon form, and you're getting only two equations, right? Because the last row is trivial. All right, but the problem is, how are we going to get the actual solutions for all three variables if I only have two relations? And therefore, this is infinite many. Okay, but the way you can get, a particular solution out of that infinite many choices is that you need to figure it out as a user, right? So now imagine that. So let's say I design the system, right? I code the calculator to get you the solution, right? You bought my program, right? You want to figure out what the solutions are. So you as a user need to specify, in this case, what do you want for the z? Because it turns out that anything you want for the z is fine. And that gives you a 1 degree of freedom, which you didn't have any if the solution has, or if the system has one unique solution. That means you tell me what that system is, put it into my program, and I spit out one solution. That is whatever it is, right? You don't get to change it. But now you can play around with the z, and z could be any real number. But as soon as you fix the z, and you see that they just rewrite the two equations, right? So once you fix the z, x and y will take corresponding values. Not all real numbers, but whatever numbers that satisfy these two equations. But how do you write the solution in a way that people realize they have a degree of freedom? But only 1 degree of freedom. There might be more than that. So of course, they'll list all three variables, right? Because you are solving for x, y, z. But you see that what they did with the z is they call out a new, I won't say a variable, it's a parameter. I hope that you realize the difference between variables and parameters. Variables are something that you don't know, and you probably don't have any control of. Right? Parameters are something that, of course, you don't know, but you have full control. What is a parameter? A parameter could be the brightness of my phone. I don't know what it is, but I can adjust it to from 0 to 100%, right? Can get it to whatever I want. So I need to input, right, what I want for the z. But instead of calling it z, I could have just take the, now sometimes people do this. So you tell me if you like it or not. X is 7z minus 5, and y is 3z minus plus 1, and z is, z. And why do you think that they take the z for z? Because they don't know what it is, right? It could be anything. So whatever you want for this guy, take it, but feed it to the x and y. Now, nothing wrong with that. But people don't like it. So if you want to write things in a professional way, go with this version. Call on a new parameter, call it t, call it s, call it whatever, a, right? Or something else, make it fancy, like a Greek letter, right? Theta. But you know that the new parameter is going to take all real numbers, right? But once you get whatever that parameter is going to get you, the z, feed it back into the y and a z, a y and an x to get the corresponding solution. But as you have infinite many choices for the parameter, you have infinite many solutions. You see that. Every solution is going to take x, y, z as an order triple. All right. Now, calculator time. So go ahead and type up everything for the letter H. Get me the reduced row echelon form. Not the row echelon, but the reduced row echelon form. And I wanted to write down the solution. I'll tell you that it has infinite many solutions, but I want you to write down the solution in such a way like you saw in a previous problem. All right, so you're not doing the hard work, but you need to interpret whatever you get from the calculator. All right, go ahead. I'll wait for a minute or two. Be careful with the negative sign. Don't use minus. Yeah, I need to reduce the row echelon form. I didn't seriously time it. I think that's about a minute already. And that's how quick you should be. Okay. If you couldn't do that, practice tonight. All right. Anyway, so here you go. Right. So if you got the reduced row echelon form, double check. All right. So now, you're not done yet, right? So go ahead and interpret it as those equations and write down x, y, z, w, right, in the proportional form. Because you do realize we have some degree of freedoms. Okay. There are only two leading variables, which are x and y. Right? The first column is x. You have a leading one. The y is also leading, but the z and the w, right? They are free. Okay. But write the solution in the way with the parameters. All right, it shouldn't be taking too long, right? Any questions? Now you can use whatever letters you want, right? As long as it's not the same as Z and W, so you can call it anything. A, B, C, theta, gamma, right? Psi, right? Epsilon, omega, right? Well, you're gonna go to college here. You see those letters on the dorm, right? So I don't get why they have to use the Greek letters, not to mention uppercase.
Oh.
So let's see. Now the first variable is x.
Why would
So,
it be X?
because they line up the variables in such a way. The first column, right? You go with whatever. Oh yeah, it's alphabetical, right? Sometimes they put the W in front of X, but since if let's say you don't know about the system, right? So it's me telling you that system goes like the first variable is X, right? Last variable is W. So you need to interpret that the same way. Okay, but nothing wrong with your interpretation because, like I said, if you're standing on a point of view of the machine, right, you don't know what those numbers are, right? But you have to see, okay, what the numbers are in a context, right? Yeah.
Here.
Mm-hmm.
You just put this on the other side of the equal sign, and then dot x equals 3 alpha plus 4. And then also, why? I understand that each line is like a variable.
Each line is an equation.
Okay.
So now see that the first row, you can interpret that as 1 times x, 0 times y, -3 times z, -4 times w equals 0.
So it's not like, oh, okay.
Now the second row, no x. Oh shoot. Yeah, no x anymore, right? Starts with the y. Yeah, the first column is x, right? Y, z, and w, or fictional based on their orders. Okay. Yeah. So we do have time to go into the 9.2, not completing it, but at least I want to get to the interesting part or the more important part of the concept of 9.2. And that's actually something that has something to do with this, where we're specifying the solution. I believe that you guys are way too comfortable with solving equations and expecting a unique answer, right? Or sometimes a couple of answers, right? Especially when people say that you have infinite solutions. You think that, well, what's the point of that, right? I mean, what are the solutions? Even though that I was able to write the solution in such a way that you can get a set of solution, whatever, however you want, right? But still, you don't probably see any point of this. And that's why 9.2 is talking about how to apply our knowledge about matrices, solving the linear system to actually solve some real world problems. Okay. Now there are actually a lot of real world applications. I believe that it was called the linear system, the theory of linear system. That was a course I took last quarter. So I'm taking a master's degree in aerospace engineering. During my spare time. That's why when I was teaching the trick, I was miserable because I have a lot of deadlines to meet, just like you guys. But that wasn't the course I took last quarter, but it was like 2 quarters ago. There was this experts in aerospace engineering, and he's directors of a lot of propulsion labs, right? NASA, right? So this guy has a heavy accent, just like me. And he's talking about the matrices, right? And the course sounds pretty simple. Theory of linear system. What are linear systems? That's a linear system. But here's the catch. Their linear system has tons of variables, like over 100 variables. So like you have to design an airplane that does the autopilot, right? And it takes almost everything into account because you let the machine, the airplane, drive itself. But if there's turbulence, right? There's a wind, and or what if someone turned off the autopilot, right? Would it be able to correct it? Would it be alerted, right? So you have to take almost everything into account, right? So, but it turns out that you'd be surprised at how many systems out there in our real life. Could be electrical system or engineering systems, right? Even financial system could be modeled. Not saying there are, but could be modeled with a linear system, right? And let me show you something that you guys are probably kind of familiar with, but you didn't realize that's something that you could model with a linear system. So I guess that a lot of you are driving, right? I guess that in Florida, especially South Florida, right? So the heavy traffic, right? Everywhere, right? On the highway, on the streets, right? It's just painful. So let's say this is maybe somewhere nearby. You guys know that the College Avenue, right? Especially you want to go through the other side, right? Come to BC. There's so many schools out there, right? And there's only like a narrow street, right? So the traffic just impossible, right? So why do you think that they have those random speed limits, and why they design the road sometimes to be a one-way street, or sometimes they have to have police officers or maybe volunteers to do the crowd control, right? Instead of having people coming in, right? So they say you don't go right until a certain time. They study for the most time, right? Sometimes they just do it, because they want, but most likely they have to study, right? Now what happens is, let's say, just make our analysis a little bit easier. We have 4 intersections, and all the roads are one-way street. I didn't realize that's that common until I visited San Francisco or somewhere in California. They have so many one-way streets. And the thing is, there's so many things going on in the city, I don't see those signs that do not enter. And I entered, and I freaked out. It was late at night, so I have to back out because, I don't know what's going to happen. Anyway, not to mention that San Francisco has those steep, right, streets, right? Sometimes it's like more than 30, 40 degrees, right? And you have to park in a way, right? Anyway, so let's say on this Sunset Drive, the traffic going from right to left, and this is 27th Avenue, right? The traffic's going down, whatever, go with the arrows. What if people want to figure it out, what is really causing the traffic jam? Or how would I know if the traffics are flowing smoothly? And guess what? They're looking at those intersections. They will see however many cars coming in an hour, how many cars leaving the intersection in an hour. If you have 10 cars coming in, 10 cars coming out, there's no jam, right? If 10 cars coming in, 2 cars coming out, well, 8 cars get stuck. That's where the jams happens, right? So now what they have to do is, based on the data, they know that at certain moment during the day, there are a certain number of cars per hour coming in and out. So let's say we're looking at maybe the College Avenue, right? So we don't know how many cars would there be at that moment on the avenue, but we know that how many cars tend to come in the morning. They know how many students are there, they know on average how many cars are coming in, right, to drop off the students. So they know, oh, in the morning there will be 400 cars an hour coming in, right? And usually there will be like 200 cars or maybe faculties, right? They don't leave, but the parents are leaving. So now what they do is they need to figure it out how many cars are stuck in there or on the road. So they have those 4 rows, right, in between the sections. They can assume them to be those 4 variables, x, y, z, w, right? To make sure that the traffic are flowing smoothly, what they do is they set up equations, taking however many cars coming in, set it equal to however many cars coming out at every intersection, right? Do you see that the first intersection, I1, the cars coming in are 700 from that row, right? 300 from the other row per hour. But at the same time, there should be W cars and a Z cars coming out, right? And you do that for all 4 sections. So you have, a fairly simple linear system, right? With how many equations? 4. How many variables? 4, right? Am I right? X, Y, Z, W. And now I think that when it comes to solving a system like that, it's super easy, right? Organize those equations in a way that lines up the variable, extract the coefficient, put into the augmented matrix, ask the computer or the calculator to solve it with the reduced Roy echelon form, right? And read out the solution. And remember that those solutions, X, Y, Z, W, are the number of cars on the street at that moment, right? So now let's see, what do you get from the solution? Do you see that we have a degree of freedom? Because there are 4 variables, but only 3 of them are leading, which are, let's say, X, Y, Z. The last variable, let's say W, or is it W or Z? I forgot. It's probably Z. And they say it's free. So now what they do is they take the Z as a free variable, rewrite, right, the Y, X, Y, and W in terms of Z, just like you did, right? So what we had is, 2 degree of freedom, right? Alpha and beta. But the question I showed you in a note, has 1 degree of freedom. Anyway, and you thought that this is pointless, right? Because I don't know what exactly Z is. Does it tell me anything? I mean, it kind of does a lot. It tells you that if you figure it out, how many cars on, where's the Z? 27th Avenue. You figure it out at the same time, how many cars on other streets. Okay, still, it doesn't sound, that very powerful, right? When it comes to traffic control, that means if you want to control the Z, you control all the intersections. If I want only a certain amount of cars, I can fine tune the Z, right? To see if, let's say, what is W? So W, Palm Drive, right? So let's say that's College Avenue. Every single morning, there's so many cars get stuck in there. I want to see, okay, what's going on? Oh, you know what? Turns out there might be too many cars on the 27th Avenue. Let's send someone, go out there and do some crowd control. Does it make sense? And therefore, if you send police officer to the street that has a traffic jam, they're not going to do anything, right? Unless they can move the car by themselves, right? So the car has been stuck there. You need to go to those places and prevent that happen. And that linear system, you see how easy to model even a complicated traffic system with a linear system? Of course, we make our life a little easier by looking at only one-way streets. What if the streets are both ways? I hope that you see the point of this is using the matrix to solve a system like that is not a problem anymore. But are you guys able to model real-world systems like that? And it turns out that scientists are now really good at solving linear systems, using it to model pretty much everything, right? But unfortunately, our world, real world is not a linear system, right? And therefore, unfortunately, I have to figure out something. And of course, like I talked about the aerospace, they use linear system to model airplane, but in no universe, airplane is linear, right? The turbulence, all the things you have to take into account, right? Even human factors are not linear. Know that we're not reacting, functioning, or making decisions, based off facts, right? Or whatever we thought is going to be positively impacting our life, we end up doing the same kind of a positive, reactions. No, because humans are irrational. But at least that there's a way for us to still do something, right? Not to mention nowadays with the technology, right? Solving for a complicated system is never a problem anymore. But if you're on a STEM route, not that I say everyone, but I'm saying that if you're into mechanical engineering, civil engineering, electrical engineering, or aerospace engineering, you name it, right? Those things are going to rely on a lot of things like this, right? But don't worry, the math part is going to be taken care of the computer, right? But they're paying you a huge amount of money to be the one who design, who model, who solve the problems, okay? Anyway, so I think that's good enough for just to get started with 9.2.